How are you, class?
We are well, Mr. Bartlik.
Alright, today I want us to discuss and understand reinforced concrete and prestressed concrete, as well as their differences, shall we?
Yes, for sure, that would be informative, because I would really like to understand and differentiate the two, I mean reinforced concrete and prestressed concrete.
Alright, let us begin. Let's be attentive please and try and take some notes for future reference.
Alright, sir.
Reinforced concrete and prestressed concrete are both reinforced with longitudinal and transverse steel bars, also known as rebar. The main function of the reinforcement is to strengthen concrete when it undergoes tensile stress. Let's take a look at the differences between the two composite materials and their uses.
Mr. Bartlik, do you mean that both the reinforced and prestressed concrete are reinforced?
Yes, Samir, but they are reinforced using different techniques, and as we discuss we will be able to understand, okay?
Alright, sir.
Let's start with reinforced concrete. Reinforced concrete or RC is a composite material used in construction. The low tensile strength and ductility of the concrete are fortified by the addition of reinforcing steel bars having higher tensile strength and ductility. During construction, steel bars are placed inside formwork before concrete is poured. Rebar can also be wired together into a steel cage arrangement beforehand. Concrete is then poured into the formwork and vibrated to remove air voids in the fresh concrete and ensure consolidation of the aggregates within the concrete mixture. It is imperative that the concrete completely surrounds each bar to ensure a strong bond. This diagram shows a rectangular concrete beam, with steel rebar as an example of a reinforced concrete member. The uses of reinforced concrete. Reinforced concrete is widely used due to its workability, strength, and availability of its raw materials. It is mainly used as the main members of a particular structure such as columns, piers, piles, beams, slabs, and footings for buildings, houses, dams, bridges, and other similar structures. Reinforced concrete is easily configured to unconventional shapes because it fills the container that it is supporting. This leads to extravagant architectural structures that would otherwise be difficult to build with other materials such as steel and wood. Reinforced concrete is also typically used in public works construction of highway paving and sidewalks. Reinforcing the concrete with steel bars gives the composite section tensile strength that allows for a robust and useful composite building material.
Very well understood, sir.
Okay, good. Now let's understand prestressed concrete.
Alright.
Simply put, it is concrete formed under stress. Reinforcement bars are placed in a form and stressed by the stretching of the bars at each end, inducing tension in the bar. Concrete is poured into the form and all around the bars while they are still being stretched. When they are released, the steel tries to resume its original, shorter, length, and adds a compressive force to the concrete laterally, giving it the strength to span longer distances than normal reinforced concrete. 2. The uses of prestressed concrete. Prestressing is used to make composite beams and piers in large-scale construction such as highway overpasses and commercial buildings. It enables the concrete beam to support weight between piers on either side. Without such reinforcing, concrete's lack of tensile strength would cause it to collapse without support in the middle. Here are 3 major implementations of prestressed concrete. Pre-tension concrete. Concrete is cast around steel bars or cables under tension. The concrete naturally bonds to these tendons while it cures. Compression by static friction transfers the tension to the concrete once it is released. Subsequently, any tension on the concrete transfers readily to the tendons. Pre-tension concrete elements are common in floor slabs, beams, and lintels. Bonded post-tension concrete. Compression is applied in situ during curing. A duct of aluminum, plastic, or steel is used in casting and follows the area where tension would occur in the concrete. Tendons are pushed through the duct, then tensioned via hydraulic jack after hardening. Once the tendon stretching meets design specifications, they are wedged in place and the duct is grouted. Unbonded post-tension concrete. Here, the individual tendons retain freedom of movement relative to the concrete. Tendons are prepared with a coating of lithium-based grease, then given a plastic-based shell, formed through an extrusion. The steel cables are tensioned against anchors placed in the slab's perimeter. This design provides the ability to distress the embedded tendons prior to repair. Simple diagram of a pre-stressed concrete. If asked, can you now differentiate between reinforced concrete and pre-stressed concrete?
Yes, Mr. Bartlik. Now I can differentiate.
Alright then, that is wonderful.